Section 4.2, Linear Regression. First of all, fill in this gap in your notes. A line of best fit shows correlation on a scatter graph. So on the right we have a very small scatter graph with just 4 points, and we have a line of best fit. It's a line that helps us to see what type of correlation there is on a scatter graph. Now, a line of best fit is a linear model that approximates the relationship between the variables. We can use this line of best fit as an estimate for what is known as a least squares regression line, usually just referred to as the regression line. Now, in AS maths, you don't really study how to calculate the least squares regression line, but we're just mentioning its name at the moment. Don't worry, we're not going to learn how to calculate it right now. But there's a thing called the least squares regression line, and it's something we can calculate in statistics, and it's actually the line of best fit. So we don't draw it just by looking at the scatter graph and trying to draw a line which is as close as possible to all the points. There are formulae we can use to calculate the equation of the line of best fit, and that is the regression line. Now, we need this line to fit our data the best. Therefore, we want to make the vertical distance between the points and the straight line as small as possible. So these vertical distances here, we want to minimize those, keep them as small as possible. However, since the points are above and below the line, so when you draw a line of best fit, and if it's a good one, then you'll have some points above the line, some points below the line. So since that happens, our distances could be positive or negative. So these above the line, we'd say they are positive distances, and those below the line, we'd say they are negative distances. And it just so happens when we add them all together, these distances, you will always get 0, which is no use to us. Doesn't matter where you draw your line, these distances will always give you 0. They will always cancel out and give us 0. So a way to avoid that problem is to square the distances, and that is to eliminate the negative values. So these distances D1, D2, D3 and D4, we square them and then they become positive, or if they are 0, they stay 0. And then we want to minimize those, and that's why it's called the least squares regression line. So the regression line minimizes the sum of the square distances, hence the name least squares regression line. So we can conclude that that line, which in second year maths you'll see how to get the calculator to work out this equation for you, it fits our data the best. So regression line y on x is given by y equals a plus bx. Of course it's a line, therefore that fits the general form y equals mx plus c. So here b is the gradient of that line and a is the y-intercept. The intercept a tells you the expected value of y when x is 0. Now in a question, x and y will have context. Now, what are they actually measurements of? So you'll need to include that context in any answers. But if you've got a line of best fit, then the y-intercept is the value of y when x equals 0. You'll see when we do examples, we'll just put that into the context of the question to give us an interpretation of the value of a. The value of b tells you the expected change in the y for every unit change in x. Again, x and y will have context in the question like this. If the data is positively correlated, then b will be positive. In other words, it'll have a positive gradient. If the data is negatively correlated, there's a missing ly there, then b will be negative. If it's got a gradient that is negative, then it's showing negative correlation. Please note the regression line is only valid when the data shows a linear correlation. I'm going to highlight the word linear. It doesn't help us find different types of correlations. So where we've got data that follows a curve, then it's no good for that. It only helps us when we've got straight line relationships. The stronger the correlation, then the more accurately the regression line will model the data. There's that word again, model. If we go back to the beginning, these regression lines, or these lines of best fit, are just models that approximate the relationship between two variables. Okay, next up we're going to do example 4.2.1.